Hi, I'm Debbie with Nixene Publishing. I'm here with Adrian Nixon from Yorkshire, England, right, Adrian?
Yep.
All right. Good morning. How are you?
Yeah, good morning, Debbie. I'm very well, thank you very much. Actually, it's good afternoon here.
True. Good afternoon. Good afternoon. Well, we are continuing our series on Adrian on the spot. And Adrian has very nicely agreed to be able to hear some of the questions that our readers have posed, our viewers have posed on our YouTube channel. Oh, here's one that's a little bit different. And this is on video number 10, Graphene and the Copper Corrosion Mystery. Don't believe that we spoke about this in our last batch of Adrian on the spot. So the question is, does copper destabilize graphene? What materials destabilize a graphene structure?
Very good question. The answer to that is almost nothing destabilizes graphene because graphene is one of the most stable compounds going. But graphene can act as a catalyst for other things. So graphene won't be destabilized, but it could destabilize other things. What was going on from memory in video 10 was graphene is made on the surface of copper. And if it was perfect graphene, it will provide an impenetrable seal. So Debbie, you know that Andre Geim and his team, the Nobel Prize winner, did some work in Manchester looking at graphene and found that a 1 atom thin layer of graphene is equivalent to a kilometer thick wall of glass when it comes to keeping things like the smallest atom known, which is helium, contained. So even helium can't pass through a 1 atom thin layer of graphene. Yet when this came out, when we were at the Geek, there is a table with lots of demonstration samples on there, and the Geek have a graphene making machine. So they've got an Extron roll-to-roll machine, which creates graphene on the surface of copper. And we were a bit puzzled because they have 2 samples of copper foil, one without graphene and one with graphene. And after a few months, I noticed on the table that the one covered in graphene, the copper had gone darker, and the original copper was fine. And we thought, well, hang on a sec, what's going on here? Because graphene ought to protect the surface of the copper, so nothing should be happening to it. Yet the copper was, because it was going darker, that told me it was forming copper oxide. There are a number of different types of oxides of copper, but one of them goes like a dark brown color or a reddish color. And that's what was happening on the graphene coated one. And it looked like oxygen was attacking the copper. But how's that possible? Then graphene protects it. And it turns out that what was going on was that the layer of graphene on the surface of the copper was not perfect. So it was polycrystalline. So it was made up a bit like a patchwork quilt, and somewhere the joins were, there were gaps. And what was happening was that oxygen was getting in through the gaps and through the cracks, going underneath the graphene and the copper foil. And the graphene was then catalyzing a reaction with the copper and oxygen to accelerate the oxidation. So it was because the graphene wasn't the perfect covering. And that's what was going on there. And that's where this all came about. And so it seemed to be a paradox. You put an impermeable layer on, protects the copper, yet the copper was corroding. And so the paradox is solved because it wasn't a perfect layer of graphene, and graphene was acting as a catalyst. So that's what was going on there. Hopefully that answers the question.
Yeah, because it sounds like if once you have the single crystal graphene nailed down on how to make that and have it be perfect, then that will be that impermeable seal.
Precisely, yes. And just for the viewers, when Debbie says single crystal, Debbie is accustomed to all these technical terms, but single crystal means a perfect layer of graphene with no flaws. So that continuous chicken wire, and nothing will be able to get through that. So you coat things in graphene and it will protect them forever. In fact, there was something, Debbie, we came across last year where they were using a 1 atom thin layer of graphene to protect artworks from corroding, if you remember that one.
Thank you so much, Adrian, for your time.
A pleasure, Debbie, and thanks again to the viewers for taking the time to message in. We'll try and do these a little bit more frequently now.